So today we are going to be factoring polynomials by taking out the greatest common factor. So as we look at example 1, you're going to ask yourself, let me get my pointer going. Maybe not. Hang on. Technical difficulties. All right. So as I am looking at the 4 and the 3, you're going to ask yourself, what can I divide both 4 and 3 by, and the biggest number. So what you might need to do is prime factor 4, prime factor 3, stretch them out so that you can see what the greatest common factor is, like we did in 7-1. However, I'm hoping that you can get past that and just look at these. Well, the smaller of the two numbers is 3. And so if you get stuck, does 3 divide into 4? No. What numbers divide into 3? Only 1 and 3. Since 3 doesn't divide into 4, the numbers themselves do not have a greatest common factor. So then look at the variables, x squared and x. How many x's can you take away from both of these and take the same amount of x's? It's either going to be x squared or x. It's not going to be x cubed or x to the fourth. It's going to be one of the ones that you see here. So if you say x squared, well sure, I can take 2 x's away from this one because it's got x squared. But I can't take 2 x's away from this one because it only has 1 x. So the most x's I can take away from both of them and take the same amount is just 1 x. It's always going to be the smaller of these two because that's the most restrictive. So my GCF is going to be, what color? I think I'll use yellow. So my GCF is going to equal just x. And let me make my pointer smaller. See if that's small enough. All right, so then we're going to divide each of these just by x. And that greatest common factor has to come out in front of parentheses. And so then we're going to divide and see what's left over. So 4 divided by 1 is 4. So I get 4. And then if I've got x squared divided by x, remember when we divide like bases you subtract the exponents, and technically there's an exponent of 1 here. So 2 of these, take away 1 of these, gives us 1x. So I've got an x, and then minus 3 divided by 1 is going to give us 3. And then as you look at these x's, anytime you have the same thing divided by the same thing, they're going to cancel each other out, because technically that's 1x, take away 1x, it gives us no x's. So these cancel out. And then this ends up being my final answer. So let's move on to example 2. Okay, so let me move this slide out of the way. All right, so let's look at example 2. So this time we have a trinomial, but we're still doing the same thing. We're going to look at the numbers first and find our GCF first. So GCF equals. Then let's look at the numbers. So we've got 10, 20, and 5. 5 is the smallest out of all 3. And so you ask yourself, does 5 divide into the other 2? And yes, because the other 2 end in 0, it follows the 5's divisibility rule. So all 3 are divisible by 5, and your greatest common factor will never be bigger than your smallest number. So therefore, for our numbers, our GCF is 5. Then look at your variables. I've got y cubed, y squared, and y. This is your smallest one, so that, and they all share a y, because they all have to share a y for it to be in the greatest common factor. And so the smallest one is the one we generally put in there, because if you say, well, they have 3 y's in common, I can take 3 y's from this one, but I can't take 3 y's from this one, and I certainly can't take 3 y's from this one. So I can take 1 y from this one, and that's the most I can take from that one. So therefore, I can also take 1 from here and 1 from here. So our smallest ends up being the one that we end up putting in the greatest common factor. And so then we are going to divide each of these by 5y. And we're going to take that greatest common factor of 5y and we're going to put it out in front of parentheses. And then we're going to divide. So we've got 10 divided by 5 is 2. And then we've got 3 y's. We're going to take away 1 y. So that gives us y to the second. 3 minus 1 is 2. And then we've got 20 divided by 5 gives us a positive 4. And then 2 y's, take away 1 y, is going to give us y to the first. Negative 5 divided by positive 5 is a negative 1. So I'm just going to put a negative here for now. And then because I've got y divided by y, they cancel out. And since I have to have something here, I can't leave it blank. And think about this. I've got the same thing divided by itself. Anything divided by itself is 1. And so we will end up having a minus 1 there. If you have 3 terms that you're dividing the GCF into, you better have 3 answers here. Never leave something blank just because everything canceled out. And by the way, the 5's also cancel out too, technically, right? All right, so then this ends up being our answer. So let's go on to example 3. All right, so with example 3, a couple things are going on here. So notice that both terms have a negative in common, and both terms have an x in common. So when we find our GCF, because they both have a negative in common, we need to factor out a negative. So let's just start there. So our GCF is going to have a negative in it. And then let's look at our numbers. We've got 12 versus 8, 8 being the smallest. Since 8 does not divide into 12 evenly, ask yourself what numbers do divide into 8. Only 2 and 4. So 2 definitely divides into 12 because it's even, and so does 4. Since 4 is the larger, we're going to use 4 as our GCF. So we're going to factor out a negative 4. Then look at your variables. We have an x versus an x squared. Again, we can't take 2 x's from this one because it doesn't have enough to take 2 from. But we can take 1 x from this one, and we can take 1 x from that one. So that's the most amount of x's that we can take and still take the same amount. So my GCF is going to be negative 4x, which means I'm going to divide both of these by a negative 4x. And a negative 4x is going to go out in front of parentheses. Then do your division. Negative 12 divided by negative 4, 2 negatives make a positive. So we get a positive 3. And then x divided by x, those x's cancel. So there will be no x in that term. Then negative 8 divided by negative 4 is going to make a positive 2. And then 2 x's take away 1 x will give us 1x. And this is our answer. You can always go back and redistribute to see if you get the original answer. So in other words, negative 4 times positive 3, there's our negative 12. X times no x, you're going to tack the x on. Negative 4 times positive 2 is negative 8. X times x is x squared because we add the exponents. So this multiplied through, distributed through, does indeed give us what we originally started with. And that is almost, oh, I think we've got one more slide. We have a word problem, so let's move to that. So even though this is a word problem, it really is no different than what you've been doing. It's asking you essentially to do the same thing. So read it. It says, Mandy's calculator is powered by solar energy. The area of the solar panel is 7x squared plus x centimeters squared. So remember that area of a rectangle, because that's what that solar panel looks like, is a rectangle. Area of a rectangle is equal to length times width. And so they're telling you that area here is equal to, I guess I can't get white as a color. That's very odd, but okay. I'm going to get 7x squared plus x. So all I'm doing is replacing. They told me here that the area of the solar panel is this. Well, the solar panel, this is not the solar panel, but if there was one, it would be right here, is always a rectangle. Area of a rectangle is length times width. So they told me that this represents the area of that rectangular solar panel, so I'm just replacing length times width with this. And then the problem goes on to say, factor this polynomial to find possible expressions for the dimensions of the solar panel, the dimensions being length and width. So we're going to factor this. As we look at the numbers 7, and technically there's a 1 here, 7 and 1 do not have a common factor. So there will not be a number in our GCF. However, we've got 2 x's here and 1 x there. The most x's I could take away from both of them and take the same amount would be 1x. So our GCF is going to have 1x. So I'm going to divide both of these by 1x. And then I'm going to take an x out in front. And then perform the division. 7 divided by 1 is still 7. And then x squared divided by x. So 2 of these, take away 1 of these, will give us 1x. So I get an x. And then the same thing divided by the same thing, those are going to cancel. So if they cancel, I have to have an answer here. I can't just leave this blank. So anything divided by itself is 1. And because of the plus, we are going to have a plus 1. And so area will equal x times 7x plus 1. And what that implies is that x is the same as length and width is the same as 7x plus 1. Answer completed. And that is the end of today's lesson. Okay, so that's the end of today's lesson, and here is your homework. Get rid of this box. And so today's homework is page 467, 2 through 11, all. Good luck, and if you need help, come see me.